This conference will now be recorded.
Good afternoon, everybody. Welcome to our TSG Trainings webinar on why AI should learn from human intelligence. Today, I've got Andy Brown with me. He's a principal consultant at Explio, been around the business a long time, just like I have. There's a picture of me talking now. I'm the owner and MD of TSG Training, and you'll be talking momentarily. Just before we get going, we will make this webinar available on our website and on YouTube. We will send you links to those, and we'll send you links to the next AI courses we've got running for at TSG Training. The next one being February the 14th and April the 15th, and that's the Essentials. Beyond that, we'll be running the Foundation probably from March, but watch our website in the BCS class category. However, it's not me you want to listen to. You've come to listen to Andy. He's the knowledgeable guy, so I'll pass you over to him now. Great, thanks.
Thanks a lot, Bernard. So my name's Andy Brown, and I'm going to be talking about why it is that we should be learning from human intelligence in AI. So if we look back about 100 years to the time when the humans, we were trying to fly, the earliest flight pioneers there, we know that the successful ones there were the Wilbur and Oliver Wright there, the Wright brothers there. And so there we can see them. That's the very first flight there, 17th of December, 1903 at Kitty Hawk Sands. Now, at the time, though, it wasn't at all obvious that the Wright brothers would be the first successful pioneers at flying, because there were a lot of other people trying to fly at the same time, including others that were far better funded, and also some others that had an established track record at inventions. So the question is, what is it that the Wright brothers did that allowed them to succeed, which other people didn't do? And the answer to that is that what the Wright brothers did is that as part of their studies, they included a study of natural flight. So they're trying to create an artificial system of artificial flight, their human flight, and they studied birds. And what this taught them were two things. Firstly, that actually the biggest problem that they faced was not the one that they anticipated, and not anyone else anticipated either. They had thought that the biggest problem they were facing was power, getting enough power to get up into the air. Now, power was a problem, but a bigger problem was actually one of control. And it was only through studying the birds that they realized this was the biggest problem. The second benefit of studying the birds was that it actually gave them a solution as well, which was that they identified how birds maneuver and turn there, which is by banking their wings. So by studying a natural system, it first of all identified the biggest problems they had, plus secondly, it also identified a potential solution. Now, I'm going to be using analogies to the way that our mind remembers. And if you're further interested in this, this is a very good book to look at here. Daniel Schacter, he was a Harvard professor. Now, Schacter identified that there were 7 sins or 7 shortcomings to our memory there. And we'll go into them in a bit more detail, but briefly they are transients, absent-mindedness, blocking. Now, those 3 types are different types of forgetting. But in addition to forgetting, we also distort our memories. And here he identified misattribution, suggestibility, and bias. And then he identified a 7th failure there, which was the opposite of forgetting, which he called persistence, which essentially is where we're unable to forget, typically a very traumatic event there. So if we start off with the first there, transients. Question would be, where did you park your car this morning? Where did you park it yesterday? 10 days ago? 100 days ago? As you go further back in time, what you'll find is that you have decreasing accessibility to your memories there. So hopefully you can easily remember where you parked your car this morning, but it's probably unlikely you'll remember where it was 100 days ago. And this is particularly true if you don't use a memory. So if you park your car in the same place, you'll remember it. But if it's in different places, you're likely to forget. So that's transients. In addition to transients, then, you've also got absent-mindedness. So this isn't where you gradually forget. This is where you've never remembered in the first place. So imagine that you're talking to somebody. As you're talking with them, you're fiddling with your keys. You put your keys down. 2 minutes later, you're looking for your keys. You can't for the life of you find them. So this is absent-mindedness. And this is where you're not paying attention. So it's inattentive or shallow processing. So you can't retrieve a memory because there's nothing to retrieve. It typically occurs when you're doing several things at once. That's when you're trying to multitask and your attention is divided between them. So that's absent-mindedness. Next, if we look at blocking. So most commonly, you might know this as tip of the tongue blocking, which is a temporary inaccessibility. Frustratingly, later on, you will get that memory back. So a couple of months ago, I was trying to remember the actor Woody Allen, but each time I tried to recall the actor, I kept on coming up with the name Alan Alda. And there's certain similarities between the two, and this was causing the problem there. Every time I tried to remember Woody Allen, kept on coming up with Alan Alda. So this also gives a characteristic of blocking, which is the Cinderella complex. So we all know Cinderella, and we think of Cinderella with the glass slipper, but also, as well as that, Cinderella's got her ugly sisters. Now, I couldn't find any pictures of ugly sisters on the web, so you just have to make do with a picture of myself and your imagination there. So Cinderella's ugly sisters, they were her undesirable but dominating sisters, and they blocked access by Prince Charming to Cinderella there. So this is typically what's happening in a blocking situation there. You've got a related item which is incorrect, and it keeps on coming up when you try and remember the correct item there. So those are the three types of forgetting that we do. But in addition to that, we've got memory distortions. And the first of those is something called misattribution. And this is where we've got some kind of memory, but we've perhaps mixed up the date, the time, the place, or the person there. The second of distortion is something called suggestibility. And this is where we will create a false memory through leading questions or comments, which are an attempt to retrieve that past experience there. A big problem in evidence and eyewitness statements. And the third one is bias. And this is where our present knowledge, our present beliefs, they will distort our memory of what actually happened. So, for example, if you're in a romantic relationship and perhaps you've been on holiday with that person earlier in the year, if you're happy in your relationship and you look back on the holiday, you will remember the happy parts of that holiday. However, in contrast, say you're not so happy in that relationship, if you look back on that holiday and you're looking back on the same events, you will not remember the happy bits. You will be unable to retrieve those events, and you'll remember perhaps the bickering, the arguments, and the lost luggage from that holiday. So now we come to the final one of the distortions, or final one of the memory failures, and that's persistence. And it's the opposite of where we forget there, where we can remember, but we're unable to forget there. Very often it may occur if you have a traumatic event, or it may be, say, if you had a meeting with your boss, it didn't go as well as you wanted, you wish you'd said some other things, or he'd said some other things there, then you may be ruminating over, I wish I'd said this, or I wish I said that. Okay, so we've now identified 7 different methods that our memory fails us. So typically what will happen is most of us have a fairly poor view of our human memory. So particularly if we look at their transients, absent-mindedness, blocking, and so on there, a lot of us, and myself included, I'm quite happy to say I've got a poor memory. And a lot of other people are the same, and including the AI researchers. And so in fact, if you asked AI researchers, they've got a very poor view of human memory. And if you said to them, well, if you're building this AI system, how about modeling the memory system of your AI system on human memory, they will just laugh in your face. And they'll say something like this. Why would I want to choose a system for my memory that is so unreliable? So what we'd have to ask is, why is it that our memory is so unreliable or so poor for its purpose? Or perhaps do we have to ask that actually, is the way that we're looking at our memory, is it actually fairly good and suited for the purpose? And what we're seeing are not actually failures there, but actually adaptations. So this type of thinking is wrapped up in a branch of psychology called evolutionary psychology, where essentially you will look at a behavior or a feature of humans and you'll ask, how could this behavior have benefited your ancestors in your evolutionary past? So we perhaps ask, what were the adaptive problems that memory had to solve? And then perhaps we come up with, there's lots of problems, but essentially they will boil down to two main problems there, which is survival, reproduction in a fairly simple but also fairly hostile environment there. And we'd have to ask, is AI going to face similar problems? So if we take each of those apparent failures in our memory, so the first one there, transients. So where do we park our car? Well, it doesn't really matter where we parked our car 100 days ago. It's not going to help us. And similarly, if we think back in our ancestral past, if instead of that car, if we'd come across a carcass of an animal, it had been killed by predators, and there was a bit of meat on it, we might fall on that carcass, eat the meat, and feast a bit there. But if every time that we went past that carcass or that area, the carcass was no longer there, would it be useful to hold on to that information? The answer is probably not. So now we come to a problem that we have with our memory. Every single second that you are awake, you are receiving 10 million bits of information through your senses, mainly through your vision, but also your hearing, your smell, your touch. That works out at 36 gigabytes an hour, which is half a terabyte a day, which is 2 petabytes in a decade. Now, 2 petabytes is an important number because neuroscientists, they estimate that this is the storage capacity of your brain. So if you recorded every single thing that comes in on your senses, not forgetting and just disregarding all your thoughts as well, not storing those, your brain would be filled up by the time of your 10th birthday. So we can see that perhaps transients, this gradual forgetting there, is well adapted to the informational needs that of our ancestral past there. Information that we no longer needed, we no longer retrieved, we gradually forgot it. And the question is AI going to face a similar problem in that generating large amounts of data? Okay, if we look at absent-mindedness now, so this is forgetting your keys, or perhaps forgetting where your spear is in your ancestral past. Now, we're absent-minded because we're not paying attention. Because in order to record the memory, we need to be paying attention. So events that are not attended to are not recorded. But think of the alternative. What if every single detail was recorded there? Now, again, we're back to this problem, but from a slightly different angle now. Every second you're receiving 10 million bits of information, but how much can you process? And actually, your conscious system can only process between 8 to 40 bits a second. So you've got a massive processing and filtering problem here. Every second you get 10 million bits of information, you've somehow got to cut that down to between 10 and 40. And at the same time, you've also got to be formulating a response. And the next second, you've got to do it again, all in real time. So you can see that without some serious filtering, we're going to get overwhelmed by a clutter of useless details. And this indeed happened to some people. Most notably, a guy called Sheriff Shersky. He was known as the Mononymist. He could record absolutely everything. So give him a date. He would tell you what the weather was like on that day. He would tell you the day of the week. He would tell you what he was doing on that day, all in extreme detail. However, he couldn't function at an abstract level simply because he was overwhelmed with the amount of information that he was being bombarded with. So again, we can see absent-mindedness, as well as being a shortcoming, is actually a very efficient mechanism to allow us to avoid being overwhelmed with clutter. And if we think about AI systems, they're probably going to have huge amounts of information coming in that they're going to need to process very, very quickly. So they're going to be facing similar problems. Now, similarly with blocking. Now, blocking is an inhibitory process in your memory, and so generally that's not a good thing. But imagine your memory without any inhibition. So we want to see Cinderella, but the ugly sisters are in the way. So let's get rid of the ugly sisters and see what happens. So terrific, we can now get to Cinderella. But hang on a second, every single potential memory that you've got that could be related to Cinderella or fairy tales or princesses, including my favorite, the Austen princess, they're no longer prevented from coming into your memory. So we can see that blocking is actually a mechanism for inhibiting competing memories. So once you've got a close enough match, inhibit the other ones. And that avoids us being overwhelmed again. And again, the question is AI going to have a similar problem that it needs to overcome there? So we've looked at the memory failures. If we now look at, if we looked at the forgetting, if we now look at the memory distortions now. So with misattribution and suggestibility, they reflect a poor memory for the source and the details of the experience. But what would happen if we retained all those details? Now, we've already talked about what would happen there. You'll get overwhelmed, so you can't do anything, and your brain's full up by your 10th birthday. So would an adapted system default to recording everything? When we build software systems and we put logging in, do we default the logging to verbose? Typically, we don't. But there's a second and more important contribution from this misattribution and suggestibility. And it's to do with the difference between the gist of an idea and the gist of a memory and verbatim. And this false recall occurs when we get the perceptual gist correct, but we get the verbatim details wrong. Now, this gist, though, it is fundamental to us being able to characterize and comprehend our memories there. And it's also likely to be central to our ability to act intelligently. And acting intelligently, that's going to be central to artificial intelligence. So if we look at the final one of the distortions here, which is bias, so we're back to that romantic relationship here. So bias is where our present knowledge and our schemas influences our memory and distorts our memory so it fits in with our current knowledge. Now, this sounds bad, but these schemas, they form a very important organizing function for us. And in fact, they guide our memory retrieval. So it's highly likely that without these schemas and the bias, which is a price of that, our memory would be nowhere near as effective at retrieving memories. A second benefit of bias is it also allows us to develop an accurate expectation of how events are likely to unfold. So if there's a predator approaching us and running up the hill, how's that likely to work out? And of course, with AI, one of the main things that we want is AI to be able to develop accurate expectations and then formulate a response on it. So the final one here is that persistence. So in that persistence there, you could imagine in our ancestral past, if that hadn't been a carcass of another species that we'd come across, if that had been our own species, we'd probably be looking at someone from our tribe, perhaps a family member, a relation, or a friend that had been torn apart by predators. We'd find that tremendously upsetting, and we'd probably have persistent memories about that for a long time. But so we should, because that could have been us that had been killed there. So when we're faced with life-threatening dangers, these cause emotionally arousing experiences, and the persistence from these memories, they give us a long-lasting protection. So to recap then, the pioneers that were successful in generating artificial human flight there were the Wright Brothers. And a major reason that they were successful when other better funded competitors there failed or were behind them was because they included a serious study of the natural system. By studying the natural system, they identified what the biggest problem was, and they also identified a potential solution there. Now, I've talked about memory here as an example, but it's not just memory, because also humans reason very well, okay? And we make decisions very well, and we learn very well. And these are three things that AI is going to have to do. And together with memory, I believe that by studying reasoning, decision-making, and learning, we can form and build much better systems than we currently are. So by understanding the mind there, AI research can perhaps identify the biggest problem, which may not be the one we think it is. We perhaps may think it's processing power or something, but it may be something else. It may be that we need to block out completing memories or completing solutions. It may also identify solutions to the problems, as we've seen with the memory there. And it may also identify problems we're not even aware of. So, thank you very much. My name is Andy Brown. I'm here with TSG. Thank you very much. Do we have any questions? No, thank you.
No, very much. Great thanks to Andy. That's very informative, and certainly a lot of things in there that were new to me. So I hope you've enjoyed that too. Remember, this, the next course on this subject is on February the 14th, April the 15th, and then that's for essentials. We'll introduce BCS Foundation in March or slightly beyond that. Thanks very much for attending, everybody. I hope you've had a great time, and we hope to see you next time. Thanks again.